Hi, today I'm going to walk you very quickly through using MolView. I just want to call your attention to the web address up here, molview.org. And when you first type that in, it's going to come up with a preloaded structure. Now, you can see if you look at this, this is in what we call skeletal notation, which is not something we've talked about yet. You only really use this when you're doing things that contain carbons. So I'm just going to give you an assignment that does not contain carbons. The nice thing about having the structure is it allows you to see how you can use this to observe the geometry of very large molecules. And so before you go on, just go over to the right half of the screen, which shows you the molecular geometry, and you can just click anywhere and drag to rotate so you can see what the geometry looks like. Before you do anything, just clear the screen. And then what you can do, and so I'm going to do the first one for you, and it's PCl5. So you can see that we're going to use the phosphorus. So you're going to click on the P and just click it in the middle of your screen. And then you want 5 chlorine, so you're going to go 1, 2, 3, 4, 5, and you want to connect these chlorines to the phosphorus. So click on the single bond up here in the upper left corner, click on a chlorine, click and hold, and you want to drag it down to the phosphorus so that you know that the chlorine and phosphorus are single bonded. Now just repeat that with the other chlorines. You don't need to put in non-bonding pairs here, but now you want to see what this looks like in 3 dimensions, and so click on this 2D to 3D, and it renders it, and you can drag around, and you can see this is our trigonal bipyramidal. Remember, we have the axial atoms going up and down, and then the equatorial ones at 120 degrees around the central atom. So that's what you're going to do. You can see there's a whole bunch of other tools here that you can play around with. So I've just cleared the screen here. And you can see, for example, you can make a double bond. So if we wanted to make an oxygen atom, let's say, you could just do the double bonds between the oxygen, render, and here's our oxygen atom. So I do want to show you that there are different ways to represent it. You can do, this is the ball and stick. Here's the stick, which just sort of assumes the nuclei are not very big. Here is van der Waals spheres, which is probably a better representation of how the molecules put together. Wireframe and line. And I'll go back to the ball and stick. Again, you're going to go ahead and just play around with this, and you can also export a 3D model image, and that exports it as a PNG, and that's what you're going to be turning in to me is the PNGs that you create. That's it. I hope you have fun with this lab.